Okay, so this is a video over the methods for solving systems of equations. I know you learned this last year, and we even did some of these earlier in the chapter, but I noticed some of you didn't know it so well, and maybe you only know one method and not the other, so this is a good chance to review all three methods. You spend a couple of weeks on this in Algebra 2 next year, so it's not a bad idea to refresh it this year so it's not so cold when you go back to it next year. Okay, so we're just going to worry about 2 by 2 system of equations, and that means that there are two equations having two of the same variables. So we'll stick with x and y, but if it were a word problem, it could be, cost and number or anything like that, as long as they have the same two variables for both equations. Okay, so there are three methods for solving systems of equations, and you can solve any system using any of the three methods, but the point is each method has its own benefit depending on what form the equations are set up in. So that's how I'm going to suggest for you to do it. Look at what form you're given, and then that's how you should choose which method you use. So let's take a look at that. So graphing is best used when both equations are in slope-intercept form, because that's the easiest form to graph from. Y equals is very easy to put on the graph. Mark your y-intercept, follow your slope, and there's your equation. So that's best from there. Substitution is best used when one equation is in standard form and the other is solved for a variable. Now, it's most likely going to be in slope-intercept form, meaning it's solved for y, but that doesn't have to be the case. It could be x equals 2y, and that would be a good substitution one as well. Okay, and thirdly, the elimination method is best used when both equations are in standard form. Okay, so let's look at a graphing one that we have here. So you're just going to graph these equations, and what you're looking for is where they intersect. So I'm going to start at -1. I'm going to go up 2 over 1. I'm just going to do this a couple of times until I can see where they're going to intersect. You can draw your line, but I find that makes me a little more confused in case my line's not very straight. So I am going to avoid that till the end. Okay, this one is at -4, and we're going to go up 1 over 2. So I can quickly see that these are going to intersect down here. So, except for this should be up 1 over 2. Up 1 over 2. How's that? But I can still see they're going to intersect in the third quadrant. So I'm just going to keep going until I can see exactly where they intersect. Again, if you just wanted to draw your line and go, you could do that, but I prefer to do this method right here where I can see exactly that this is the coordinate that they share in common. So then I can write that coordinate is -2, -5. Okay, y'all pause here and try B. Okay, so for B we have -3x plus 2, that's this line, and 2x minus 8, that's this line. So here they are intersecting at 2, -4. Okay, now remember with systems of equations, you can check your answer by plugging it back into the original equation, and you can use your calculator to do that. So if I wanted to check this one, I would say, okay, 2 times -2 minus 1. That would be -4 minus 1. And that's -5, and that's what y is supposed to be. So I can tell that's a good answer, and I could do it again with that one. Same thing here, I could plug in x and see if the right y comes out. So that you should never miss a system of equations problem, because you should always be checking your answers every single time. Okay, now I forgot to bring home my graphing calculator to show you this, so I'll just kind of talk you through the steps and we'll do it in class on Monday. So if you happen to have your calculator, like it's not a non-calculator part of a test, you can make your calculator find the intersection for you instead of having to graph by hand. So you start by you put one equation in y1 and the other equation in y2, and you go to the graph. Then you press second trace, which second trace is the calculate button. We want our calculator to tell us where, so we calculate. Number 5 is the intersection point, and then you just hit enter, 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 and it will tell you exactly where those two things are intersecting. And we'll practice that on Monday so you can actually see it. Okay, so this is substitution. Remember, substitution is when one is in standard form and the other is solved for a variable, usually y, but could be x. So what we do with substitution is we take the equation where something is solved for a variable, and we take the other stuff. So in this case, the x plus 2, and we take that and we substitute it into the other equation for that given variable, so for y. So in this case, I'm going to plug x plus 2 into y spot. So what you do is you pretend like you're rewriting the second equation, the one in standard form, but instead of y, we put x plus 2. So instead of saying x plus y is equal to 8, we say x plus 2 is equal to 8. And then we just solve from here. This is 2x equals 6, so x is equal to 3. Okay? Once you get that, then you just go and substitute it back in. And usually, it's the easiest to substitute it into the first equation that you took the material from. So this would say x plus 2, which would be 3 plus 2, is equal to y. So that tells me y is equal to 5. So your answer is always a coordinate point. So 3, 5 is the coordinate where these would intersect. Again, you should go and plug it back in to make sure. 3 plus 5 is equal to 8. It's equal to 8, so I know I did it right. Okay, here's one like I was telling you that it doesn't have to be solved for y, it could be solved for x. So it's the same kind of deal though. I'm going to take all this information and I'm going to plug it into x in the other equation. So I'm going to have 2 times not x, but 2y minus 1 plus 3y is equal to 26. Then I'm just going to distribute and solve. So 4y minus 2 plus 3y is equal to 26. That would be 7y is equal to 28. So y is 4. Take y and plug it back into the other equation. 2 times 4 minus 1, x is equal to 7. So the coordinate point would be 7, 4. And again, you should go and plug this into your equation to make sure that it works out. Okay, so 14 plus 12 is 26. That works out. Okay, y'all try C, and then see if you come back and see if you get it right. Okay, so C is very similar to A. I substitute x plus 7 in for y, so 2x is equal to 10, so x is equal to 5, and then plug that back into the other equation. 5 plus 7 is 12, and then you can always check that 5 and 12 is the right answer there. Okay, last one is elimination. Elimination, you are looking to have the same coefficient but an opposite sign. That way when you add the two equations together, that one variable with the same coefficient and the opposite sign, they'll cancel each other out. Now sometimes you'll be given a gift and this will already be in the same coefficient opposite sign. Most of the time it won't, so you will have to multiply one or both equations by something to force it to have same coefficient opposite signs. Okay, so let's look at A here. So neither of these have the same coefficient and opposite sign, so I'm going to have to make them. So you look and see which one would be easier to make. Well, obviously the one without a coefficient would be easy. So I want the coefficient to be 3 so that it matches the other equation, but I want them to have opposite signs. So since this one's positive, this one needs to be negative. And then I just distribute that negative 3 all the way across, including over to the right side of the equation with that negative 1. So this is going to read negative 3x minus 18y is equal to negative 3. It's very important that you multiply it all the way across. Otherwise, you've just changed the problem and you've gotten the wrong answer. The second equation I didn't do anything with, so I'm just going to rewrite it. Then, now when I have the same coefficient but opposite signs, I'm ready to add the two equations together. So that variable cancels. This variable is negative 13y is equal to negative 13, meaning y is equal to 1. Okay? When you're done, same story as with substitution, you plug it back in and plug it into an original equation, not after you multiplied, but one of the two original ones. Okay, and you can plug it into whichever one's easier. So I'm going to plug it into this one. So x plus 6 times 1 is equal to 1. Move the 6, and x is equal to negative 5. So my answer is negative 5 1. Now, take this and plug it back into this equation to make sure you did it right. 3 times negative 5 is negative 15, plus 5 is equal to negative 10. That's good, so I know I did it right. Okay, y'all try B. Okay, so for B, I didn't have either. I couldn't just multiply one equation or the other. I had to multiply both. So I multiplied the top equation by 2 and the bottom equation by negative 3 so that the x's would have 6x and negative 6x and they would be ready to cross out. Now, if you multiply this one by negative 2 and this one by positive 3, you're going to get the same thing. Okay, also, if you chose to eliminate the y, so you multiply 1 by 3 and 1 by negative 4, that would work too. It's just whatever's easier. I always choose the smaller number so that I don't have to multiply so big. Okay, so this one, when I multiply by 2, I got 6x plus 8y equals 12. And here by negative 3, I got negative 6x minus 9y equals negative 9. So negative y is equal to 3, therefore y is equal to negative 3. I took that and I plugged it back into the bottom equation. 2x plus 3 times negative 3 is equal to 3. Added the 9, divided by 2, and I get x is equal to 6. And then you can tell I plugged it back in to make sure I got the right answer. Okay, so just a couple of each kind. It's supposed to be a review. If it's not a review, we'll work on it in class on Monday. If it still doesn't work for you, then come into tutorials because this is the last new topic before the test. See you Monday.